Hello students, welcome all of you in today's lecture. Students, we have solving the problems on stapler cross-section bars. In previous two lecture, we are solving two problems on that type of bar. Then in today's lecture we are going to solve another problem, but today's problem is a little bit different from previous two lectures. Okay, then what is the problem of today's? A bar ABC is actually loaded as shown in figure if the maximum stress induced in the bar is 100 MPa. Calculate the value of P. Also calculate net deformation of the bar. Take E is equal to 102 GPa for both parts. This question is asked for winter 2017 for 8 marks. That is for G scheme paper. This problem is asked. Okay, I am repeating the problem once again. A bar ABC is actually loaded as shown in figure. This is the figure. If the maximum stress induced in the bar is 100 MPa. Calculate the value of P. Also calculate the net deformation of the bar. Take E is equal to 102 GPa for both parts. Okay, this is the problem. So students, in last two previous problem we seen the stapler cross section of bar. On that bar there are variety, that is various forces are acted, that is horizontal forces, but the values of that forces are different and they act at different cross section. Okay, but in this problem you can see only one force is applied, that is compressive axial force is applied. Okay, this compressive force is coincide this axis of that bar. Okay, this compressive axial force is applied on that bar, and due to this bar the maximum stress is 100 MPa. The maximum stress developed is 100 MPa. Okay, stress maximum and minimum is developed, that is maximum stress developed due to variable the area of that bar. AB having area, that is this AB is circular cross section. Okay, having area, that is the diameter of that AB is 16 mm diameter and the diameter of the BC is 12 mm diameter. Okay, that is the area of that two bar are different. Okay, hence the stress developed in this bar are two types, that is minimum stress and maybe maximum stress. Okay, minimum stress because if we consider the maximum area this, then the stress developed on that bar is minimum and the stress developed on that bar is maximum. Okay, how is it we will see later. Okay, then this P is, we have to calculate the diameter is given 16 mm diameter and 12 mm diameter. The length of the AB is 400 and length of the BC is 300 mm. Okay, then write this given data. They give the maximum stress sigma max, that is maximum stress is 100 MPa. They give value for Young's modulus, that is for both part is 102 MPa. The length of the part AB is 400 mm, that is L1, and length for part BC is 300 mm, taken as L2. Okay, then diameter D1 is equal to, that is diameter for the bar AB is 16 mm, taken as D1, and diameter for part BC is, that is taken as D2 and it is 12 mm. Okay, from that diameter we can calculate the area of bar AB and BC. Okay, then here we have to find value of for P, this is compressive axial force which is acted on this bar. Here we have to find out this value of P, and net deflection, or that is net deformation of the bar due to this force P. Okay, that is deformation means a delta L. Here we have to calculate. Okay, then come towards the solution of that problem. Okay, first calculate the area, that is A1 means area for AB. The diameter is given, D1 is 16 mm. The bar is circular, hence use formula pi by 4 into D1 square. Okay, then pi by 4 into 16 mm square, and the answer will be equal to 201.062 mm square. Okay, then area for area for part BC, this is also circular in cross section, hence the formula pi by 4 into D square, that is D2 square, that is pi by 4 into D2 is 12 mm. Okay, that is the, by calculating we get the value is 113.097 mm square. Okay, these two area we get here. Okay, A1 for AB, A2 for BC. Okay, then next find first P. Okay, P, that is force, compressive force. Now here we don't use here the equilibrium condition. There is no required to use equilibrium condition, because here only one type of force is applied. One force is applied. If different forces are acted, then we want to use the equilibrium condition, but only one force is applied here, and here we have to calculate this force. Then they give the value for maximum stress, that is 100 MPa. Okay, we know the formula for stress. We know stress is equal to P upon A. Okay, then stress is equal to P upon A. Here stress and A is inversely proportional to each other. Stress and A, that is stress and value of area, and area is inversely proportional to each other. Okay, that means if the value of A is minimum, then stress will be maximum. Okay, and if value of A is maximum, then value of sigma, that is stress, will be minimum. Okay, then here they give maximum stress. Okay, they give maximum stress, sigma max. Hence here the formula becomes P upon A minimum, because they are inversely proportional to each other. When we use A minimum, we get maximum stress. Okay, if we use A maximum, then here stress will be minimum. But here they give maximum stress 100 MPa, hence we use sigma max. Okay, then by comparing these two areas of that bar, the minimum area is 113097, that is area A2 is minimum, that is area of part of BC is minimum, it is 113.07097. Use this area here minimum, and maximum stress is given. Then by using this value we get value of P. Okay, maximum stress is 100 MPa is equal to 100 MPa means 100 Newton per mm square is equal to P upon A minimum. A minimum is 113.097. Okay, then calculate P is equal to this value we get multiplied and answer will be 11,309.73 Newton. Okay, this is the value for P. 11,309.73 Newton. Okay, then calculate the deformation of the bar. Deformation of bar. We know the formula for delta L is equal to delta L1 plus delta L2. That is, total deformation is equal to deformation of bar 1 plus deformation of bar 2. That is deformation of bar AB plus deformation of bar BC. Okay, deformation delta L1 plus delta L2. Then we know the formula for delta L is P1 L1 divided by A1 E1 plus P2 L2 divided by A2 E2. Okay, then use all these values. Delta L is equal to, here the value of P1 and P2 are same because only one P, that is common P, is here, only one P. Hence P1 and P2 kept common, that is same, and value of E also 100, that is this is also same for both parts. Okay, here this value E is equal to in GPa, that is E is equal to how much? 102 GPa. It convert in Newton per mm square, it become 102 into 10 raised to 3 Newton per mm square. Use this value. Okay, E is equal to 102 into 10 raised to 3 Newton per mm square. Then delta L1, that is keep P and E as common because P same for both parts and E also same for both parts. Then it becomes there here by formula L1 and E1, L2 and E2, sorry, L1 divided by A1 and L2 divided by E2, L1 divided by A1 plus L2 divided by A2. Okay, then value P for P is 11,309.73 divided by E is 102 into 10 raised to 3 in bracket length L1 is 400 mm divided by area is A1 is 201.062 plus length L2 is 300 mm divided by A2 is 113.097. Okay, and by calculating we get the value for L2, sorry, by all calculating the value will become 0.515 mm. This is the delta L. Overall deflection of that bar is 0.515 mm. Okay, that is, this bar is compressed, hence length is decreased by value 0.515 mm. Okay, here the value, the problem is over. Thank you.